May 30th, 2020. It's a big day. Today was the successful launch of the SpaceX rocket that took two astronauts to the ISS, the International Space Station. And it's important for a number of reasons. The first one is that this is a commercial rocket, meaning that it's a rocket owned by a private company, and the company is the same company that produces the Tesla motor vehicles. And so NASA is just basically kind of borrowing it to bring these two astronauts up to the International Space Station. The second big thing is that this is the first time that we have in 9 years from US soil launched a rocket up into space to carry, in this case, carrying two astronauts to the ISS. The last one was in 2011, and that was the final mission of the space shuttle, and since then it was retired. And we've been using since then the Soyuz rockets provided to us by the Russians. So this was another big milestone. And just today, on May 31st, in the morning, we had the successful docking of the SpaceX capsule to the International Space Station. So a pretty big weekend when it comes to space exploration, and it serves as a great background for us to start this unit on space. I think for many of us, the first exposure that we have to space or the topic of space is through stuff like science fiction. So whether it's through movies, video games, or whatever. I know mine started back with Star Wars, Star Trek, and television shows like Battlestar Galactica, all of those kinds of things. Getting into stuff like cartoons, and then even later on in movies like Contact, and even up to stuff like The Martian. These have just opened up, through science fiction, your eyes or my eyes to something like space. And it is fascinating out there. One of my favorite scenes to open up a movie, which was Contact. I love this clip because it essentially puts into perspective where we here on Earth fit into this greater thing called the universe. It's a fantastic opening, and I just love the fact I remember sitting in the movie theater having it completely silent as this clip rolled out. And it brings us to today's topic, which is, where are we in all of this? How do we fit into this? The first thing that we'll talk about is our cosmic address. Where are we in the universe? Well, we start off with what planet we're on, Earth. And Earth is part of this solar system, the other planets, as well as our sun. Now, this solar system is part of many other solar systems, stars and planets within this galaxy called the Milky Way galaxy. Now, how many potential stars could we see in the Milky Way galaxy? Well, they estimate somewhere between 100 to maybe 400 billion stars. And they would say that when it comes to galaxies, the Milky Way galaxy is kind of like an average-sized galaxy. So far our address is Earth, solar system, Milky Way galaxy. Now, the Milky Way galaxy is about maybe one of about 50 other galaxies that we sort of know of in this group called the local cluster. Now, the local cluster is another small part of a much larger supercluster called the Virgo supercluster. And this larger Virgo supercluster contains roughly around, again, an estimate of about 50,000 other galaxies. The Virgo supercluster is but one supercluster among maybe 10 million other superclusters that we see in our observable universe. So you can get a sense right away, it's mind-blowing, but you get a sense as to just how large this scale is that we're talking about. Starting with planet Earth, going to our solar system. The solar system is part of the Milky Way galaxy. The Milky Way galaxy is part of our local cluster. And the local cluster is part of the Virgo supercluster. And the Virgo supercluster is one of millions of other superclusters in what we would call the observable universe. That is our cosmic address. So let's back this up a bit. What do we mean by the universe? Basically, the universe is all the matter, space, and energy that exists. That's what it contains. And that's basically everything around us. These objects that we talk about that exist within this universe, like planets, like Earth, our local star, the sun, but all the other stars that are out there, the groups of stars and galaxies, comets, asteroids, all of these things that are out there, we would call those things celestial bodies, these objects that exist within our universe. So within that address, that cosmic address we just talked about, there were a number of terms. Now you already may be familiar with a lot of these terms, like galaxies, and we describe galaxies as being these sort of large collections of stars, planets, and other debris like dust. And that is what we call a galaxy, and we belong to the Milky Way galaxy. But there are other terms, like stars. Well, what are stars? Well, stars are basically these giant balls of gas that are undergoing these really violent series of nuclear types of reactions or explosions. And that's the reason why when we look at our own sun, which is a star, you have this bright intensity of light and heat. That is the result of these really powerful chain reactions of nuclear reactions, explosions happening within that ball of gas. And then we have planets. And planets are different than stars because planets don't give off heat and light. We would define planets as these relatively large celestial objects that orbit around a star. And not only that, they sort of independently orbit around the star, that there's nothing else in that path, in that orbit that they're sharing it with. That's what a planet is. And they're finding now more and more that a lot of these stars do have planets that orbit around them. Moons, on the other hand, are celestial objects that will orbit around a planet. So here you have a star with planets that could orbit around that, and other objects that would revolve or orbit around the planet. We would call those moons. And you're going to find out later on that not all planets have a moon, and some planets will have several moons. All of these celestial objects, the energy, this all belongs to the observable universe. And what do we mean by the observable universe? It's basically the universe as we see it or observe it. The reason why we call it that way is because we have not seen or observed all of the universe. At least that's what we think. Just because it is so large that the light from the far reaches of the universe have not had enough time yet to reach our eyes. So as a result, we just can't see it yet if there is anything out there to see. So the question is, well, how did the universe get here? And that's where this theory of the Big Bang comes into play here. The Big Bang theory offers the explanation that the universe started as a single point. And you can't even say that outside that single point was empty space because space didn't even exist at that point. But from that single point, a rapid expansion. And to keep things really simple, through the different collisions of matter, antimatter, we start seeing the formation of energy, light energy. We start seeing the formation of stuff that would go on to become our atoms. This expansion out and the gradual cooling of this space would go on to become the universe as we know it, which continues to expand to this very day. Now, how did this all start out? American astronomer Edwin Hubble was tracking celestial bodies, specifically galaxies, and the movement of galaxies relative to us and relative to each other. And he found out that galaxies were really sort of moving farther and farther apart from each other. And as he tracked this, he started noticing that the universe was actually seeming to expand outwards. What were they moving away from? Playing the movement in reverse, started noticing this really interesting trend where things would start to move closer and closer together to a particular point. That was really the supporting evidence that they were using to support the Big Bang theory, that the universe really started from a single point. And within that point, all the matter and energy that exists in the universe today. Now, that theory has continued to undergo a lot of criticism and reviewing and challenges, and now there is other evidence to suggest that maybe there is this expansion and contraction, an expansion and contraction of the universe. This field of study is really interesting, and it's really unlike the other fields that we've looked at so far. Chemistry and biology, you can sort of do in labs, you can go out into the field, you can make observations, it's right there, it's right in front of you. Astrophysics, you're looking at distances that are so large and looking at a scale that's so immense. The approach is different. It really is different. However, with that said, Space really is about us because we are part of this universe. And we abide by the same laws made up of really the same materials that are out there in the known universe. And so understanding space in many ways is helping us understand us. And I'm hoping that you'll get that from this unit. All right, that's the end of the lesson. I'm keeping it short because I want to give you some time to look through some of these other items that I've posted up in Google Classroom. 2 clips for you to take a look at. One just sort of reviews the cosmic address. It's the clip that I was actually using during the actual lesson, but I love the way that Neil deGrasse Tyson narrates it, so it's a nice review of what we just covered. The other clip is something from Carl Sagan. It's an old clip, but it's something that I want you to take a look at and listen to because it really illustrates the uniqueness of life here on Earth, and that everything that we know, all the history and even the events that are currently going on today, it has all taken place on this one planet. And again, sort of lets us think about where we are in this universe. There's nothing special about the video. I have not taken them and sort of mashed them up or anything like that, so don't expect some weird voice or animation to happen. But I want you to take a look at them. The third video is really about explaining what the work is for this unit. This is going to be different because there is basically one assignment, and it's going to be due that third week of June, June 19th, I believe is a Friday. And it's basically how I'm going to evaluate you on this unit. And it's going to allow you to bring in all these things that we are going to be talking about in this unit, including the stuff from today, and hopefully put it in a way that allows you to sink your teeth into it a little bit more. Space is weird because I can't give you like a simulation lab. There's really not a lot out there. There's also, I'm posting up basically a textbook, and it's the thing that we used last year. It's basically the notes for the unit. So I'm giving them all to you up front so you can take a look at them, but you'll notice that as you go through lesson to lesson to lesson, the stuff that we talk about in these videos and in my lessons are basically referring to the stuff that is in this, basically this Earth 2.0 manual. So those are your notes. You don't have to worry about printing that out because we're not going to be doing a quiz on this. This is going to be a one assignment that you'll be handing in on June 19th. And there is a video there that explains a little bit more about that, and we can talk more about that as we go through it. That's it. That's what I want you to do today. And yeah, have a good one. Start up space. Here we go.